Good evening, everyone, and thank you for joining this webinar on behalf of the Northwest branch of the IIRSM. Tonight's speaker is Matt Clay. Matt has very kindly offered to provide us with a speech and a presentation on barriers, enablers, and technical feasibility of cross-industry process safety data sharing. Matt is a principal engineer at the Science and Research Centre of the Health and Safety Executive, the HSE, in Buxton in the UK. His work involves supporting HSE's regulatory and policy activities, as well as working on commercially funded work for the public and private sector clients. Matt works in a group which includes process safety, risk assessment, and human factors specialists who commonly focus on major accident hazards, MAH. Matt has recently completed a PhD with the School of Engineering at University of Manchester, which examined the use of natural language processing, NLP, to extract insight from free text records containing process safety information. Matt works heavily on the Discovering Safety programme, which is funded by Lloyd's Register Foundation. This is a wide programme of work aimed at extracting value from safety data using innovative techniques. So without further ado, I will hand you over to Matt. Thank you.
Brilliant. Well, thanks very much for that introduction there, Lee. That's appreciated. And what I'm going to do is talk to you for about 40 minutes approximately, just about the topic that Lee described well there. It basically links to some research work I've been doing for my PhD, but also a project within the Discovering Safety programme. So I'll tell you a little bit about that project, but the main topic and focus of the work is some interesting research we've done around surveys and also some experiments we've done with trying to extract insights, which I'll tell you about. So just in terms of the content then, so I'll give you a bit of background and scope to the Loss of Containment Insights project, which is the sort of vehicle by which I've been doing this research with other colleagues in the organisation. We'll have a quick look at data needs in process safety and also answer the fundamental question or attempt to explore, do you actually need any data at first at all? Because that's actually quite an important and non-obvious question to ask. We'll have a look at some RAMS data and I'll explain what that means when we come onto that. And then I'll talk you very briefly through what is quite a complex piece of work, which is using natural language processing or NLP techniques, which are basically those means which we can use to extract individual insights from fairly chaotic, unstructured free text of the type that you might get within, say, a PDF document or a Word document or a database which contains unstructured text data, basically. And then you're lucky enough this evening to be getting a sneak preview at some results from a survey that we haven't yet published, but we will be doing soon. And this was really around looking at barriers to sharing process safety data across industry. We've been very interested in this, but we've recognised from quite an early part in the project that actually that's quite fraught with difficulty. So we're quite interested to understand industry's views around data sharing, and I'll talk you through the survey. Ultimately, the sort of work we've done experimentally and also looking at industry's appetite for sharing has resulted in a number of conflicts, and I'll be quite sort of candid with you about the nature of these conflicts because they are fundamentally difficult things to examine. And then I'll talk about some of the enablers and what we're hoping to do with the programme moving forward and summarise that. And then, as we said, I'll have a chance to answer some questions at the end. So hopefully that will be sort of an interesting canter through what's been quite a long project lasting sort of up to 4 years at this point. So I'll just give a quick shout out to the funders of this sort of vehicle. So first of all, the Discovering Safety programme is a programme. It's got multiple projects within it, and many of those projects are not relevant to major accident hazards. They're related to occupational safety and health, which is obviously very important. And many of the projects actually within the programme are construction related. My colleagues are working quite closely with some major construction companies and other stakeholders within the construction sector. So my project, the Loss of Containment Insights project, sits within the Discovering Safety programme, but it's actually the only major accident hazards stroke process safety project that exists within there. The whole programme, the Discovering Safety programme, is funded by Lloyd's Register Foundation. So I'm sure most, if not all of you, will have heard of Lloyd's Register, the commercial arm that goes and does consultancy and does certification and verification exercises on ships and offshore installations, etc. What I wasn't aware of before we started this project and programme was that Lloyd's Register actually have a charitable vehicle called the Foundation, which actually funds interesting and useful safety engineering activities. So we're very lucky to have had that funding for the Discovering Safety project and programme from Lloyd's. And we're delivering this through an entity which has been created called the Thomas Ashton Institute. And this is a multidisciplinary institute which is created from the strengths of HSE as a sort of regulator and researcher, but also the University of Manchester, who bring the sort of academic rigour, peer review, and all those good things. So it's quite a large programme. The funding for Discovering Safety was £10 million over 5 years. And as I say, there's multiple projects, and this is literally just one of them, and a fairly quick sort of overview at that. But I'll try and do my best within the sort of 40 minutes to tell you what it's all about. So I'm sure I don't need to remind people on the call of the importance of process safety. And here are 3 incidents which probably highlight some of the negative consequences of not managing process safety well. So we're probably all familiar with the Bhopal toxic release in India back in 1984. Very difficult actually to get a sort of definitive death toll from that incident. You know, the official deaths are shy of 4,000, but actually many estimates put it at 16,000 or even more. And obviously people suffered from chronic ill health as well as the sort of acute toxicity of that incident. So again, you know, onshore toxic hazards are important to understand and to manage. And then closer to home, obviously, there's the Buncefield fire and explosion back in 2005, which was actually a time when I spent, I'd just joined the coma regime, and Buncefield happened. So as you can imagine, that was a fairly steep learning curve for myself and other colleagues that had joined that unit at the time. Unfortunately, as you'll be aware, there were no deaths resulting from Buncefield, but there was a huge economic impact resulting from the fire, both in terms of the asset damage, but also the impact on the economy, because obviously, as you're aware, Buncefield was a key strategic site for fuel within the UK, and in particular for airport fueling. So that had a major impact. And then also, we've not got to forget the offshore and also the maritime sectors. And this event on the right here was a floating production unit, so a ship that's basically a oil production and storage unit. And that resulted from a failed condensate pump, which resulted in initial fires and explosions, sadly resulting in 9 deaths and also major £200 million repair claim. So when these incidents do happen, obviously they have a massive impact on the public, on workers, on the environment, and also indeed on assets. So that's the background to why we need to take account of process safety. So just in terms of some of the terminology I'll use, and I guess many of you will be familiar with this, but the project's called the Loss of Containment Insights Project. The idea being that basically when we keep the unpleasant, flammable, toxic materials within containment, all is well in the world. And when we start to lose that containment, that's when we get problems such as fires, explosions, and toxic releases. And so we use the term primary containment to mean that containment that's actually provided there in the first instance to keep the material where we want it. So this is things like tanks, vessels, pipelines, and so on. And really the aim is ultimately to try and keep the products within the design envelope and within that primary containment. But also we recognise, of course, that incidents occur. So we could have tank overfills, as we saw at Buncefield, but also other process upsets such as runaway reactions and so forth. And so we actually provide secondary containment. So this is oftentimes things like bunds, balms, and also sort of other containment mechanisms, so membranes and things which basically stop product from leaving often the site or the immediate area around a tank or vessel. And then finally, we have tertiary containment, which is often the site drainage system and the associated infrastructure with things like interceptors and separators and things of that nature. So we're trying to reduce the frequency and the consequences of loss of containment events. And what's unique about this project is that we're really looking to do this through understanding unstructured and chaotic free text data. And the other important reason that we're doing that, as well as that being inherently useful, is that we realise that field staff are quite time poor, and many initiatives which aim to collect coded data have basically been in decline because obviously organisations are run on lean principles, and often people simply don't have the time to do a very elaborate data collection methods. So the idea of this project is really to take data that already exists, be that industry data or the data that exists within HSE's regulatory environs, and to try and apply some techniques to it to extract that value, but without having to make people click boxes and codify insights themselves. Okay. So just to looking at data needs in process safety, and I've put wants or needs here because the fundamental question is, do you actually need data in process safety? Or as the one of the bullet points says here, is it enough just to comply with standards, guides, codes of practice, guidance, and that sort of thing? And we have this term RAMS, which is reliability, availability, maintainability, and safety. And these are sort of distinct but linked concepts. And the traditional view of these concepts is that they are largely separate. And that's not actually a view I subscribe to, because I think they are very inherently linked. The conventional argument goes something like this, that basically you can have a very reliable system, but an unsafe system, or alternatively, you can have a very safe but unreliable system. I think that's a bit of an oversimplification, because I've certainly investigated many accidents and incidents where something that started off as a reliability problem would end up having major safety implications. And so just to give you one example of that, I once investigated an accident where trace heating on a pipeline had failed and the product had solidified in it. And the operators at this particular site had engineered a sort of bodged bypass arrangement in order to resolve this problem, and then lost ton quantities of a material as a result of doing that. And similarly, if you look at things like a fire pump, clearly the availability of a fire pump and its standby and things has an impact, or could have an impact, on safety. So my own view is, yes, they are distinct things, but we need to understand the difference. But I think they are clearly linked. And in fact, RAMS data sources are used in process safety, augmented by judgment. So people will use within risk assessment data sources which were primarily started with an aim of reliability, and then use judgment to assess the impacts of those, and use other techniques as well, like fault trees and so on. So I've been looking as part of my research at these coded data, RAMS data sets, and one of the things that's very clear is that there's been quite a decline in the prevalence of these data sets since the 1980s. But of course, there are some good exceptions to that. So many of you will be familiar with the IIRSM dataset, which is largely offshore, but does apply to onshore as well, which is a very elaborate and rigorous data collection initiative, which has stood the test of time. But as I said earlier, we know that field staff are time poor, and that we can't really start imposing new data collections on people. And just in terms of the sort of need for data, as well as sort of it being useful and necessary for certain process safety activities, there are actually explicit legal duties within COMA in respect of the major accident prevention policy and safety management systems duties, that basically you're required to provide information on past accidents and incidents with consideration to what's relevant and practical, And importantly, there's a requirement that you do that not just within Great Britain, but beyond it. And actually, that's quite a challenging thing to actually achieve, because whilst there are some databases which exist to help you with that task, they do have a very small number of events within them. And it's quite challenging to actually benchmark in a fairly rigorous way against other operators within your sector and other sectors, and particularly around the world. Looking at some specific activities, hazard identification. So, for example, HAZOP and the guidance that exists around HAZOP methodology would say that you need to have access to some data so that you augment the knowledge and the engineering judgment of the people that are fundamentally in the HAZOP team, that you actually need some data in order to back that up. But where data is most critically needed is risk assessment, and in particular the sort of more sophisticated techniques, so LOPA, laser protection analysis, and full quantitative risk assessment. It's highly likely or almost certain that some data will be needed. So there is a need for data. You can argue about how important that is, and it does differ depending on which sector you're particularly working in. But I think it is important, and obviously data is not an alternative to doing all of the good stuff around standards and guidance and all of that stuff and engineering judgment, but it is important. So what we're trying to do really is, this is the sort of knowledge pyramid. There's various different versions of this, and this is one. And really it shows the progression of where we start off with data, which is just basically individual observations. So in here we have an example. This is just a hypothetical example. But this shows that one example would be the vessel overfilled when the high level trip failed and the operator lined up the wrong tank. And that's obviously a useful observation, but it doesn't necessarily help you to trend or to actually do something. You know, what do you actually do with that one data point? So we then progress into information, which is more about looking at generalizable patterns from that underpinning data. So we might look at how many percentage of records show vessel overfilling events and what we could learn from those. And then we move into to knowledge, and again, there's slightly different terminology. So you'll see insight and various things, but within this pyramid, knowledge is basically trying to generalize that from the information and come up with more sort of generalizable, useful findings in terms of the problems. So we might find out that, for example, a particular percentage of vessel overfill events will involve failure of a high-level trip, for example. But again, that's useful, but it's not actionable. And so the top of this is really wisdom, and you'll also hear the phrase actionable insight. And this is really stuff we can do something with. So an actual insight here based on the material. As I said, this is just a hypothetical example. But what we're trying to do with the project is basically take the data, which is quite chaotic and exists within free text, and try and progress that up this pyramid, ultimately to give people that wisdom to decide, you know, what more can we do in order to improve process safety performance. So that's what it's all about, fundamentally. And I've always liked this phrase, all models are wrong, but some are useful. I think that applies to many things. And this is our taxonomy that we use to understand and extract some of the features from the free text. Why are all models wrong? Well, this is a simplification of what actually happens in reality. And I think it's been very apparent from the research that we've done that actually many incidents progress in a highly non-linear way. And this obviously shows progression from a hazardous substance through initiating events, deviations, so things like high temperature, high pressure, to loss events. What actually happens when you look at the data is that it's much more non-linear than this, and you can get various different feedback loops and other things which make it much more complex. So this is a vast oversimplification. And I think, I can't remember who it was, but someone once made the analogy with accidents, and in particular sort of technical safety accidents, that it's more like a tube map. So you can get to a particular point in a particular accident through many, many different routes. And again, you know, people are familiar with the Swiss cheese model, which was intended to be quite a holistic and complex model, but actually people oversimplify it and think that there's a very linear progression with incidents, and that's certainly not what we see from the data. But nevertheless, we have to have some model in order to make the techniques work, but we have to sort of apply this with sense, basically. Now, I've got an apology to make here because I'm going to upset anyone that's a whiskey drinker, but I just wanted to give you an example of the sort of event that we have. So this is obviously it's anonymized, but this is an event from the COMA regime. Believe it or not, many distilleries are subject to the COMA regulations because they store such high concentrations and quantities of ethanol, so alcohol. So this here describes the loss containment of quite a large quantity of spirit, so high concentration ethanol, and in the distillery following the smashing of a sight glass, which was used for sort of product quality reasons. And this failure of the sight glass happened sometime before the sort of the event, but when product transfer was started, the product was lost out of that. And there were various other protective means. So we have our secondary containment operating here. So all of this was successfully captured in a bund. And the bund also had a liquid level sensor in. And the action of that ceased product transfer operations when that spill was lost into the bund. And another control measure that was in place was that this particular operator had ATEX rated equipment around various things. And because of that and other features, no ignition occurred, and then basically this operator was able to recover fully that. I don't know whether that would have actually made it into a whiskey product, but I think it's obviously it was all recovered and no injuries occurred. So you can see from this sort of text-based example, there's some color coding at the bottom, which indicates some of the features that we are looking for within the sort of free text in order to extract process safety insights. So we have things like deviations, initiating events, and so forth. This obviously shows that there are particular segments within the text which basically extract those features. In practice, there's many examples which are much more complicated than that, and you'll find that there's insights that's buried across different sentences and paragraphs, and that's one of the challenges that we have when we try and make this work, basically. So this is just some of the early results. So this is us trying to extract some features. So one of the features we try and extract from free text is impact. So this is ultimately what happens. Is it fatality, non-fatality? Were the site evacuation? Was there damage to assets, and so forth? And the accuracy figure there is basically how accurate the natural language processing NLP techniques are at automatically extracting these features. And the way that we've done this is that we've done a classic sort of machine learning thing for anyone that's into that, and we've basically coded a number of records, and then we've used a trained network to basically predict the outcome, and then compared that and come up with a simple accuracy figure. So you can see for something like impact, perhaps unsurprisingly, sort of around 93%, although it does vary depending on the exact feature that's been looked at. When we come to something like deviation, for example, the accuracy drops off, and you'll see there's quite a range of accuracy variations within that category as well. So this is really the sort of initial experimental work that we've done, which is promising. But what we're finding is that some features are much more easy to extract than others, and this doesn't necessarily line up with what people are wanting to extract, which is something I'll come on to shortly. So where we've got to so far is that these NLP techniques do work credibly. We didn't know that apart from some literature which suggested it might do, but it's been useful to actually do the work to actually find that out. We also found that some simpler techniques tend to work better at scale. So when we're looking at volume of records, hundreds and thousands of records, there are people in the literature who advocate some very sophisticated techniques, but actually they're extremely onerous and they don't seem to add the value that's claimed for them. As I said, some features pretty easy to extract, as you might expect, and some features, and in particular sort of underlying and root causation, are absolutely not easy to extract. We've also done some subject matter expert trials, which is where we've actually had process safety specialists and trying to extract the same insight we're trying to do with automated means to try and understand, can humans agree? Is this a subjective thing or an objective thing? So we've run those trials, which have been very interesting. So we basically had a problem, which is data needs in process safety. We had a potential but flawed solution. And what we wanted to do was ask industry what they thought, what they'd want to get out of such techniques, and any issues around data sharing. Because the ultimate aim with an idea of this is that we would have HSE's regulatory data, we would have industry's data, and we would pool all of the insight from those different sources and then be able to sort of share those for the benefit of everyone. We found out fairly early on that there's a number of barriers to this, so we wanted to be a bit more objective and understand that in terms of a survey. So this is what we did. So one of the things we asked people for was to basically highlight the sort of information that they want to get out of a process safety insight exercise based on our NLP techniques. And unsurprisingly, possibly, was root causes came out as the number one thing that people were most interested in, followed very, very closely with human factors aspects. We also wanted to know whether people were happy with qualitative or quantitative information, because obviously for some process safety activities like risk assessment, often the need is quantitative. So what were people's attitudes to whether qualitative information was desirable or not? And I think it's a bit of a mixed picture there in reality, because whilst interestingly qualitative came out slightly in front of quantitative, nevertheless they are both significant features within the survey responses. Technical causes, so again, perhaps not surprisingly, I think what surprised me somewhat is that the ability to benchmark across and within a sector was not as important as I perhaps expected it would be when compared to some of the other features like root causation and so forth. But again, it still features there, but it just gives an interesting flavour as to what people's interests are within this sort of work. Also, we wanted to understand barriers to data sharing, and for this we used what's called a forced voting technique, because one of the dangers with a survey where you say, what are the barriers, is people just say, well, all of the above, which doesn't really help you. So this survey question and the next one basically involved forced voting. So people had to choose their sort of top three, which kind of narrows down the findings. And again, none of these really came as a particular surprise to me, but there were these sort of reputational damage aspects. The release of personal data was very significant, and also that was very significant in terms of the free text comments that people actually made when they responded to this question, because they were very concerned. And I think you'll have seen in the news recent events where there's been significant data breaches and the impact that has. So it's perhaps not surprising that this comes out as a very significant one. Also, obviously, commercial confidentiality being a big issue. Even if personal data could be removed, there's still that issue. And then one thing that people were very candid about with us, which I'm glad they were and didn't come as a surprise, is that there was a concern around scrutiny of regulators. So obviously at the moment we're running this project through HSE, which is a regulator, although I work in the research side of things. But obviously, there's some concerns there, and that has some implications for how we take things forward and how we potentially share data if that's feasible. So just mindful of time, I'll crack on somewhat. And we shared with the survey respondents a number of different models for how the issues that were in the previous slide could potentially be overcome. So the number one thing that came out was that people felt that data anonymization was a key metric, a key measure, if you like, in order to share data. And I think one of the interesting things about anonymization is that it's quite a technically complex task with free text, and we've done some experiments on the rest of the Discovering Safety program looking at data anonymization, and it's quite a challenging thing in that basically no automated means gives you 100% anonymization, and in fact in some cases it doesn't even get anywhere sort of close to that, depending on the complexity of the text. So you might, in some instances with very complex text, you might get to 80% or something like that. And the other problem is, of course, even if you manage to redact, i.e. remove and black out things like people's names, locations, and so on, it's often quite possible to infer sort of information from other information that's present in the text. So, for example, that given the specialist nature of some of the process industries, if we reveal that particular chemicals are being processed in a particular way, that might, and that it's in the UK, that might enable you to identify one organization, for example. So other things we explored with the respondents were the sort of trade body route. So you might have a trusted trade body who would basically collate data and then share insights from it. The other is sort of data codification, so bringing data together before it's sort of pooled and shared if possible. And then there are sort of more formal options, such as a data trust, which is a sort of limited company set up purely for the purposes of sharing data, and various other sort of options. So again, there wasn't although anonymization was there, I think when we've explored this separately with industry and they become aware of the barriers, I think it rapidly becomes apparent that that's not enough. It might be a requirement, but it's not enough just to simply have anonymization built in there. And so where we get to is that we have these set of conflicts, which is what we're kind of exploring further on the project now. So I'll just go through these, because I think this is really the absolute key part of the presentation. And I think if I've bored you senseless for 35 minutes, you might just want to pick up now, because this is really where we've got to. So one of the first things is that end users want that root causation data, which is not a surprising finding, I guess. We're all schooled in the world of safety and engineering to try and get to root causation, so that we can put in place measures that prevent not just that accident but similar ones. The difficulty is that even with the subject matter experts, there's quite a lot of subjectivity around what is a particular root cause in a particular case, and also there's many examples of free text where there is no commentary about root causation, and it's kind of very inferred from the different data that's there, and it's arguable as to whether automated techniques could ever get there. Similarly, human factors data, again, not surprised that people want that, given the role of human factors in general in safety, but also in particular in process safety and preventing major accident hazards. And we've obviously been liaising closely with our human factors colleagues on this, and one of the difficulties is that the human factors observations, which are contained within the free text, often don't have that sort of bigger picture information which HF people would be looking for. So it might contain information about the initial sort of slip or lapse or whatever, but in terms of some of the contributory factors, so equipment design, fatigue, and so forth, the information may either not be there or is very difficult to extract with automated means. It's quite clear that people want access to cross-sector industry data. So then again, a lot of the data sharing initiatives that have worked in the past have been very niche and very narrow in their focus. But again, there is a risk aversion around data sharing outside of what I'd call the sort of trusted friends. Again, the quantitative data, people do need that quantitative data for risk assessment practices, etc. But the difficulty, of course, particularly with the sort of natural language processing type work, is that we don't have that underpinning plant population data. So it's difficult, if not impossible, to establish rates, failure rates and things from this data with any sort of reliability. So that is an issue. We also found that trade bodies are trusted custodians of data, which is a good thing, and again, perhaps not surprising. But again, a lot of trade bodies tend to represent individual segments within an overall sector rather than the whole process industry, for example. Anonymized free text lets people do their own analysis. So one of the ideas we had in the very early stages of this project was, could we actually provide the public or engineers with direct access to anonymized free text from incident data? And I think that's unfortunately, with the best will in the world, is not going to be possible because of the challenges associated with reliably redacting, i.e. anonymizing that information. And I think even if you got to sort of 90% plus rates of redaction, I don't think people would be best pleased if, you know, if a bit got through, you know, because it's quite sensitive for very good reasons. And also people want both personal and commercial data to be protected, which is fine. But even if you can remove the entities, which is often a phrase used, so names, locations, organization names, and that's not easy, then you can still retain commercial data, which you can infer from the free text, given the specialist nature of what the process industry do. So this is kind of where we're at the moment. I think we've got a way forward for the time being, but I just wanted to be completely transparent that these are the sort of fundamental issues with the work that we've been doing. So what we've found and what we're doing is we're continuing to use these NLP techniques to look at other features and to try and improve the number of records we're looking at. And we're using exclusively HSE's own regulatory data at the moment. We're extracting coded insights from records, and we don't have any intention to release anonymized free text. There may be a role for anonymization in terms of where the data is stored and things, just to reduce risk. But there's not an intention to release that free text directly, which is a shame, but I think that's just the nature of what we're trying to do here. We are looking to develop a prototype web app. So this would be a sort of database type app where you'd be able to search through incident data, looking through the coded information we've managed to extract. And we will be launching a prototype at some point, probably, I would guess, sort of early 2024. We're hoping to do that. That's in development at the moment. And more recently, we discovered some principles called the open algorithms methods, which are basically used a lot in healthcare. And this is a sort of some fairly sophisticated ways in which we could potentially address some of the industry data sharing issues by basically keeping industry's data at rest with industry, and basically there being a means of extracting that data and compounding it and avoiding some of the issues. Very complex area, and there's lots of governance around it, as you might expect, because people have to be able to trust it as well as it actually being trustworthy. We have found that the NLP works do have the ability to provide useful meaning that can help us to improve process safety performance, but as with everything, it's not a silver bullet. And obviously the caveat is that all of this data stuff is very useful, and but it's sort of in addition to everything you do already, not instead of. And I think just finally, a little bit of a pessimistic note to end on perhaps, but I think some of these NLP approaches have been oversold, and I think it's quite important that when anyone's exploring these, that they're fairly transparent about the downsides as well as the upsides. And I think you've probably all seen with, you know, ChatGPT and things, the value of things like that, but also some of the drawbacks if people use it without being a sort of intelligent customer. So I think that's very important. So I think I've absolutely excelled there in landing on 40 minutes there. So I think Lee's collating any questions, so I'll pause there. Thank you.
That's great. Thank you very much, Matt. I'm sure I'm not alone in saying that your speech and your presentation were really informative and certainly thought-provoking. So yeah, I've got a few questions here, if you don't mind. The first one was, who are the key companies that are involved with developing NLP technologies?
Okay, well, that's a great question, actually, because the NLP techniques have actually largely been developed outside of science and engineering, and that actually creates us some challenges. So, for example, some of the methods in NLP are based on social media and news articles, and that does actually cause us some problems, because obviously there's some very specialist terms within science and engineering and so on. So what we're actually doing is we're actually using tools. We're using open source tools, i.e. free tools, and we are basically adapting NLP techniques that have been used in other sectors to this domain. And what we're also doing is we're bringing in topic discipline experts. So we're bringing in process safety professionals to sort of reality check what comes out. So it's a very pertinent question, because these techniques were not designed originally with science and engineering, and in particular process safety in mind. But as we found with the experiments, they can work very credibly. So yeah, I hope that sort of makes sense. But it is an issue for us, and it does cause us some problems.
Right, yeah, brilliant, thank you. The next one is, how can people get trained on using NLP techniques?
Right, okay. Well, I think it's a very steep learning curve, I would say, because I came into this pretty fresh, really. And I think what we're finding is that there's a lot of sort of tech organizations which are both offering NLP type services and also training for people to use these techniques. And obviously, as with anything, there's a huge spectrum of these techniques, from very simple to very complex. And at one end, there's the sort of, people often use the phrase text mining. So there's some fairly very simple techniques that can be used. I think what we found is where we're going with this is that we will have to, or we want to bring the best of domain knowledge with the best of data science, if you know what I mean. So the idea is that we will probably end up with partner organizations who will do some of the more sophisticated stuff, because we're still at a fairly sort of prototype at this time. But also, I think the other important point is that what we're trying to do here is also develop tools which will mean that people won't have to become an NLP expert in order to interrogate this. So the vision for the web app is that you will basically, like a conventional database, you'll be able to subset. So you might say, for example, well, tell me the top 3 initiating events in tank overfill incidents, or something of that nature. So that and that's done in a very user-friendly sort of environment.
Yeah.
So it's a good question, because it can get quite complex, and we're reliant on data science professionals. But I think the key thing is to bring the domain knowledge and the data science together. I think it's important.
Yeah, absolutely. Another one is, are there career opportunities for being either an NLP developer or possibly a super user?
Yeah, well, I mean, I think one of the big sort of growth areas in the UK generally, not specifically in safety, but it includes safety, is that data science generally is a very growth area. And obviously data science doesn't just incorporate NLP, because it's looking at numerical data, and retailers use lots of data science techniques to understand consumer behavior and all of that sort of good stuff. So I think certainly anyone that's sort of interested in getting into sort of data science, I think it is a good career, and we do have challenges ourselves with recruiting and retaining data scientists, because it is an in-demand profession, if you like. But I think one of the things we would advocate is that need to bring, I know I keep coming back to this, but to augment the domain knowledge with data science, because I think there have been a lot of experiments with what are called unsupervised methods, where you basically just throw a load of data at something and try and find patterns and things within it. But actually, what we find is the supervised methods, which bring the domain knowledge and the tacit knowledge that experts have, together with the data science tools, is the way forward, really. And I think that's a big challenge for society, really, because that's quite a luxury to be able to do that, I think.
Yeah, that's really encouraging. Thank you. The final one I've got here is, NLP a form of AI? And if so, is it potentially dangerous?
Yes, well, it is a form of AI, yeah, and
Yeah.
basically, there's several things in common between lots of different sort of AI methods, and NLP is a subset. I mean, NLP comes from linguistics meets computing, basically. So it's kind of a bit of a strange sort of amalgamation of two quite different disciplines, really, originally, in terms of where it came from. And certainly, if you look at the sort of the most recent developments, so large language models, so most people will be familiar with ChatGPT and things like this. It's so yes, that ChatGPT and the methods it uses are effectively natural language processing tools. You know, that they're sophisticated, but they are nevertheless within that category. And I think like any tool, and it's going back a bit to the sort of all models are wrong, but some are useful. I think the real important thing is that people understand the limitations, because absolutely there are risks with this, and people are talking about doing things like automated HAZOP and things like this, where you're more reliant on AI to do the work that traditionally would have been done exclusively by humans. And then there are other people who are looking at sort of decision-making aids for HAZOPs and things like that. So my own personal view is I think that it's kind of a mixed blessing, really. I think that there's great power in using some of these techniques and tools, and we can do things that would never be feasible if we got humans doing them. So, you know, imagine trying to manually go through 1,000 process safety records, for example. You know, it'd be absolutely soul destroying. But I think obviously you've got to be mindful that there are great drawbacks with these things. And I think one of the particular concerns I think we need to be aware of is that the apparent plausibility of some of these techniques, if they're not properly understood and challenged and so on. So with these large language models, for example, where you've got, you know, chatbots effectively and things, they can provide extremely plausible human sounding responses to questions which are completely and utterly wrong. So, you know, it's the usual thing. If you're going to use a tool, and it's like any software tool or any methodology, you know, you've got to kind of be aware of the limitations, and I think challenge some of the and be critical, as you would with any other form of information. And I think the other thing is that this is very much, these techniques are additional to, they're not instead of all the other good stuff that we do. So you know, nothing else in process safety has gone away. It's not a magic solution, but unfortunately some people are sort of peddling or hinting at peddling this sort of stuff as a cure-all, basically. So yeah, it's interesting.
So will there be a requirement for enhanced governance, then, you feel, around this technology?
Yeah, I think that's inevitable. Basically, I think there's no way that couldn't happen. I think given some of the implications, and I think that's quite an inherently difficult thing, because I mean, one of the problems with the whole sort of machine learning, artificial intelligence thing is that even people who design the system don't necessarily know what's under the hood. So they know how it's been set up, but actually, you know, the repeatability and things is not there, and it's extremely complicated, and you don't necessarily know how it will perform in novel situations. But I mean, we've very much got AI on. This is in terms of wider HSE, AI on the agenda, because obviously there's lots of developments in all sorts of applications. So obviously autonomous vehicles in the workplace, for example. I mean, obviously autonomous vehicles on the roads, you know, using AI methodologies, decision-making tools in process safety to augment HAZOPs and things, and then the sort of NLP to try and extract things. And I think there's great opportunities within this, but there's also huge threats. So I think the governance arrangements are key, really. Yeah.
Excellent. That's great. Thank you. If anybody else has got any questions, if you'd like to raise your hand, and then we can unmute your microphone. No? Okay.
Nothing come into chat, Lee. Nothing,
Okay.
and no questions that you haven't already asked.
That's great. Thank you very much then, Julie. Well, I think on behalf of the Northwest branch of the IIRSM, I'd like to thank Matt once again for such an interesting speech, and also
Thanks,
to all of you taking time to dial in and attend this webinar. The session will be uploaded to YouTube so in the near future, so if any of you would like to watch it again, it will be available. Yeah, and if there's nothing else, I'd just like to say have a great evening. Goodbye from Northwest Branch, and also from Matt Clay. Thank you very much.
Thank you, everyone.
Thank you, Matt and Lee.
Cheers. Thank you. Bye-bye.